All right, so this is some old school stuff. This is some old algebra skills. But this kind of stuff is really, really likely to show up on Thursday for those of my juniors that are taking SAT this week. So we're going to do a real quick refresh on these exponent rules. When we have fractions like this one, number 4, what are we going to do with our exponents for our C's and the D's? That's c to the 5th over c squared. What are we going to wind up with? C cubed. Because what we wind up doing is we wind up subtracting those exponents. So we're going to have c to the 5 minus 2. Or c to the 3rd. Same thing with that variable d. We're going to subtract those exponents. We're going to have 3 minus 2. It's going to leave us with d to the 1st. On the second one, we're going to have to do it in a couple of batches. And I recommend we go in a kind of PEMDAS-y style where we simplify what's inside our parentheses first. So let's simplify this bit and then cube it. So just like we did in the first one, we're going to simplify each chunk. I'm going to have 6 over 2. And 6 over 2 is 3. We're going to do x squared over x. X to the 2nd minus x to the 1st. Gives us just x. Oh, that's the wrong color. And on the y's, we have y cubed over y. 3 minus 1, it leaves us with y squared. This whole thing is still being raised to the 3rd power because all we did was simplify what's inside. So there's our simplifying part. And then we're going to do our power over powers. It feels like distribution. It's not, but it feels like the same thing. Where I take this exponent to all of the exponents in here and we multiply them together, including the 3, including the x. So I'm going to make a pit stop over here where we have 3 to the 3rd, x to the 3rd, y to the 2 times 3. So we're multiplying all these exponents because that x has an invisible 1 as an exponent. The 3 also has an invisible 1 as an exponent. So when we go through to simplify, 3 to the 3rd, that's a value we know. 3 to the 3rd, that's 27. We're going to put our x to the 1 times 3, which is 3. And y to the 2 times 3, which is 6. So this is our fully simplified answer set, or our fully simplified answer. Oop. The chance of there being exponents and exponent laws on Thursday's SAT is incredibly high. I can almost guarantee there's going to be something with exponent laws on the SAT. Okay, so make sure we remember how to do this. What we're going to do today as far as us-wise is we're going to learn how to put logs in the calculator today. So if you do not have a calculator, not talking your phone calculator, if you do not have a yellow calculator nearby, go get one. The phone calculators are obnoxious when it comes to doing logs. I'm not saying it's impossible, but it is a extra challenge mode, and we don't like to do challenge mode. So we're going to talk about 2 different kinds of logs today that we can put into the calculator. Because if you look at the calculator, Boop. Get it? We do have a button that says log. But if I push on it, it doesn't let me pick a base. It just tries to make me put in an argument right here. So we're going to talk about what it's actually doing for us today. Because what we have is something called a common logarithm. And what it is the common log, the one that's in your calculator, is base 10. So if we just write log without a base, and notice we go straight into the argument, that means log base 10 of whatever the argument is. So if there's no base written, it's an implied 10. And so the one in our calculator is log base 10, which is cool, but only minorly handy because, I mean, how often did we write base 10? There's actually another logarithm button on the calculator that we're going to work with today too. And we used it last chapter when we were getting to the E button. So if we write, just like don't really have a place to put it, I'm going to put it in here. So if we have log, and then we put a base of E, remember E from our PERT stuff? There's another button in the calculator that's for that. It's called LN. And this is called the natural log. It does not feel natural, but it is. So, natural. I don't know why I'm writing this in the middle of the paragraph, but I am. So our common log is a log base 10, and it just says log. The natural log is a log base E, and we write it as ln. And we're going to work with these two. We're going to practice using them on the calculator and finding values that way, and how we can do that even if we're not given a log base 10 or a log base E. So we're going to start by looking at our common log, and we are asked to evaluate these. And we don't necessarily have to do these with the calculator. We can still use our BPA log BAP stuff. So when we're asked to evaluate, that means we're asked to find that power. But this just says log of 100. Remember, this is log base 10 because it's a common log. So we want to know that 10 to the what equals 100. Well, 10 to the what does equal 100? What's P going to have to be? 2. And if we go to the calculator and we try it there, our log, it's the one right underneath the second button, of 100 tells us 2. So we're matching up. So log of 100 is 2. Same thing down here. We're going to have log base 10 of 10, or common log of 10. If we switch this around to try and do it the old school way, we can do this one. We're going to have 10 to some power equals our argument of 10. So what does that power have to be? 1. Or we can go over to the calculator and go log of 10, and it's going to spit out a 1. This is where we start to really see this happening. Log of 5. Well, I still have my base of 10, I'm still trying to find that power. So we're going to have 10 to some power equals 5. That I don't know off the top of my head. So what we're going to do is we're going to use our calculator. We're going to do the log of 5. And we're going to get grossy gross numbers. And that's okay. Logarithms are going to give us gross values. We're going to usually take it to 3 or 4 decimal places. Let's do 4. And we're going to round. That's actually going to make that go up. So we're going to have 6990. So this equals 0.6990. So we couldn't get this by switching the form around. If we can get it with switching the form around, that's not too bad. But when we don't have nice tidy numbers, like this one down here, log base 10 of 8, we're just going to type them in the calculator. So this one, I'm not even going to rewrite it in exponential form. I know there's no exponent that I know off the top of my head, 10 to the something, that gives me 8. So we're going to go to the calculator and do log of 8. And we're going to take 4 decimal places. 1, 2, 3, 4. Boop. This rounds and makes it go up. So we have 0.9031. Questions on these ones? Okay, we're going to keep working on them. So here's the other one I was talking about. Log base e of x is the same as ln of x. So I'm going to start with switching this one into logarithmic form. We have e to the x equals 12. So we're going to do our BPA log BAP with this one. I'm not a huge fan of the way I organized it, but whatever. So when we rewrite this, we have a base of e. So we're going to have log base e of my argument, which is 12. And it equals whatever that power is, which is x. Well, we just talked about how log base e is also known as ln of x, or ln. So we could rewrite this as ln of 12 equals x. Because log base e, I'm going to grab a highlighter. Log base e equals ln. So log base e can become ln. That's a button on our calculator. So we're wanting to evaluate here the ln of 12. So ln is actually right below our log button. Looks like this. So the button looks like this. ln of 12. And it's going to give us gross numbers, and that's okay. Because we're going to have 2.4849. And again, we're just going to kind of generally take 4 decimal places. It's kind of the vibe we have. 1, 2, 3, 4. Boop. That is not going to do anything for my rounding. So 2.4849. So x, ooh, that's not a pen. X equals 2.4849. These next two, we're just going to type in the calculator. So we're going to have the ln of 5, the natural log of 5, log base e of 5. Those things all mean the same thing. So we're going to type them in the calculator. We're going to have ln, which is up here, of 5. And it gives us a funky decimal, and that's okay. We're going to take 4 decimal places, 1.6094. And our last one that we're just going to type in the calculator here before we figure out how this is super helpful when we have a gazillion bases we've used, very rarely were they tens. So our last one was the natural log of 1, which is 0. Any log that has an argument of 1 gives us an answer of 0. So it can still do those really common ones. It can still do whole numbers. It can still do pieces we would know by switching forms. Yes, sir. Yes. Marriage pass. All right. So the way this helps us is we have something called a change of base formula, where I can switch my log into any other base that I wanted, but we're going to use the common log or the natural log. So I can take a log of any base and make it be something that we can do with the buttons on our calculator. Because our calculator won't let us do log base 2 or log base 5 or log base 7. It'll only do log base 10 or log base e. So this change of base formula allows us to find different ways of typing it in the calculator. So you're going to want to have this down. And it genuinely does not matter if you use natural log or common log, whichever button you prefer, I guess. Because what we do is we're going to take our log, whatever log we have. So if we had, for example, I'm just making one up right now, log base 5 of 12. We're going to set up a fraction, and we're going to put the common log or the natural log. I'm going to do common log, and then I'll write the natural log one as well. So we can do the common log of whatever our argument is. The argument goes on top over the common log of my base, whatever the base may be. So it switches it into 2 different logs, but it makes them both something we can type in the calculator. Or you can do the natural log. It's the same vibe. You'll get the same answer. Instead of doing common log, you could do ln, the natural log of 12, over the natural log of 5. And the reason we have this is because, again, my calculator cannot do log base 5 of 12. It just can't. It doesn't have the computing capabilities to hold that much logarithmic information in there. Back in the day, before calculators that could do logs were a thing, you either had a slide rule, which you've never seen one of those, they look crazy, or they'd keep an actual physical book of logarithmic values, and they'd have to look them up like a phone book or an encyclopedia. So they'd have to keep a physical log of them. So they had to make it things that they could find or look up. In this case, we have to make them something we can type into the calculator. So we could actually evaluate these. We could go to the calculator and type them in, which is exactly what we're going to do on this one. So I want to evaluate log base 5 of 12. So on my calculator, I can say, okay, calculator, I have a fraction. Second column, third button down. On the top, we had log of 12. And on the bottom, we had log of 5. So I can now type in my log base 5 of 12 in this kind of weird and convoluted way and get an answer. 1.5439. We're going to take 4 decimal places, so that rounds us up. So 1.544. So we get 1.5440. I'm going to also type it in with the natural log, and we're going to see if we get the same answer. So again, I'm going to set it up with my fraction button. I have a fraction. On the top, we have the natural log of 12, so ln over ln of 5. And we get, and you can see, looking between the two lines here, exactly the same thing. So it genuinely does not matter if you use the common log or the natural log, whichever one is your vibe, whichever one you're feeling at the time. So we have the exact same solution, 1.5440. So we're going to practice using this change of base formula today because this is how we're going to get exact answers when we don't wind up with whole numbers. Holy emails, Batman. I just got a bunch of them. Okay, so we're going to look at these. There we go. So we are going to evaluate these. So I'm going to rewrite this using my change of base formula. This is equivalent to writing a fraction with the common log of my argument for whatever the big number is, that's going to go on the top, over the common log of my base. This guy. The easy way to kind of remember that is if you kind of draw a line through it, the base kind of goes on the bottom and the big number kind of goes on the top, if that helps you remember it. But we're doing log of 4 over log of 6. You could also do common log or natural log of 4 over natural log of 6. Same deal. So we're going to do our fraction, second column, third button down. Log of 4 over log of 6. And we're going to get our 0.7737. We're going to take 4 decimal points. When we're dealing with logarithms, it's kind of a commonly done rounding because that gets you close enough in physical land to do 4 decimal points. So we're going to have 0.7737. So then we're going to do our natural log of 5, ln of 5. We don't have to do a change of base here This is already a button on the calculator. So we can just straight up go in with ln of 5. ln's a button on the calculator. It's right here. So we're going to take our 1.6094. We can do our change of base stuff, even if there's decimals in here. That's totally fine. We're typing them in the calculator anyway. It doesn't matter what it is. So I did the last one as the common log. I'm going to do this one as the natural log just because I can. It genuinely does not matter if you do common log or natural log. So we're going to take the natural log of our argument, so 1.8, over the natural log of our base, which is 3. And then we're going to type it in the calculator. It does not matter which one you use, common log or natural log, as long as you don't mix and match. You cannot do common log over natural log. You have to pick the same thing for both. So we're going to have our fraction. I did ln this time of 1.8 over the natural log of 3. And we're getting 0.5350. Okay, questions on these ones? Okay, so we're going to do one more page like this where we're evaluating and practicing and writing them in the calculator. And then I'll give you guys the homework for the next couple of days. Except it might just be for... No, we gotta have to do that. Okay. Oop. Oh. All right. So we're going to figure these ones out. Let's rewrite this using our change of base formula. What's going to go on the top? Like this? 2? Log of 2. What goes on the bottom? Log of 4. So we're using the common log on this one. We're switching this from a base 4 to a base 10 so that we can type it in the calculator because we want that decimal answer. So in our calculators, we're going to do the fraction log of 2 over log of 4. And we get 1/2. So this is one we maybe could notice on our own if we remember our exponent laws really, really good. But it also might not. Let's take this second one and switch it around with our change of base formula. What's going to go on the top? We have log base 3 of 7. How do we switch it around? Log of 7 over log of 3. Exactly right. And then again, we can type that in the calculator. That's what this is all about, is making these things something we can put in the dang calculator. So we're going to the fraction with the log of 7 over the log of 3. We get 1.7712. I'm just taking 4 decimal places. That's what I keep drawing that line in. 1.7712. And then our last one. This is our last one for the day. Let's do this one with the natural log. So it's going to be the natural log of what? 85 over the natural log of 12. It genuinely does not matter, but I don't want us to be in the habit of doing common log every time, because there are going to be some times when we need to use ln for stuff. So we're just going to type it in the calculator. The fraction, the natural log's right here, underneath the log button. Whoop. 85 over the natural log of 12, I think. All right. Yay, I'm remembering right. I couldn't remember. So we're again going to take 4 decimal places. 1, 2, 3, 4. This makes it round up, so we have 1.7879. Okay, questions on these or how we put them in the calculator or anything like that, or in general in here? Okay, so I'm going to pass out homework 3. The front page combines together yesterday's and today's. So it's solving using the common logs. We'll do some of those tomorrow, but you can also probably figure them out. So we'll do a few of those tomorrow, and then I'll show you why we really early. So we'll do some solving stuff tomorrow. Number 2 on the back is what we did today. Number 3 is a story problem that we're going to do tomorrow, which is part of the reason we have logs. Okay, so you guys have almost 10 minutes until the announcements start. So you guys can start working on this, asking questions, all that jazz. That was way more than 4. Here's what it is.